Okay, so let's look at the order of transformations, the correct way to graph multiple transformations at once. So just like PEMDAS, when we're graphing transformations, we want to make sure we are doing in the correct order, because if we flip-flop things around, we might end up with the wrong graph. So it's always super important. You're always going to start inside the parentheses and work your way out. So you're going to start as close to the x as possible and work your way out. The first thing you're always going to do is your horizontal translation. Remember now, that's your left and your right. So if there's an option to move the graph left or right, that's what you want to do first. That's going to look something like f of x equals square root of x. And it's going to be a number subtracting or adding inside your parent function. When that happens, if it's a negative number, it's moving right. If it's a positive number, it's moving left. So for example, if I had f of x equals the square root of x plus 4, because I'm adding 4, that's moving left 4. I can use a different parent function. I can have f of x equals the absolute value of x minus 2, and that's going to move to the right 2. But it has to be inside the parent function in order for it to be a horizontal translation. Those are the first things we're going to do when we're graphing. We're always going to move left and right first. After we've moved left or right, we're going to stretch or shrink the graph. So stretching or shrinking the graph is a little bit more complicated because there's multiple options. If I'm looking at my parent function, f of x equals, let's use absolute value of x. I can have a number outside that's multiplying or a number inside that's multiplying. Both of these would be considered stretching and shrinking. They're going to be my next step. So after I move left or right, then I'm looking for any numbers that are multiplying in order to perform those transformations. So now if it's outside, that's a vertical stretch or shrink, and it's going to be a vertical stretch when you have a whole number. Whole number. It's a vertical shrink when you have a fraction. If you have the number multiplying inside the parent function, then it's a horizontal stretch or shrink. And it'll be a horizontal stretch when you have a fraction and a horizontal shrink when you have a whole number. So they're opposites of each other. And the easiest way to think about this is if, for example, let's take this beautiful circle. If I take it and I stretch it vertically, so I grab this point and I make it taller, or let's see, maybe if I draw an oval it'll be easier. Okay, so if I take this point and I stretch it vertically, it's getting taller, but it's getting narrower as it gets taller. So because it's getting taller, it's considered a vertical stretch but the same thing that's happening is also considered a horizontal shrink. Whereas if I take it and I stretch it horizontally, it's getting bigger horizontally and skinnier vertically. So they're opposites, because when one thing is happening, the opposite is happening in the other direction. So if I were going to look at an example of this, for example, if I had f of x equals 2 square roots of x, this is a vertical stretch of 2 because it's outside, so that told me it was vertical, and it's a whole number, so that told me it was a stretch. Versus if I had f of x equals 1/4 x squared, this is going to be a vertical shrink because it's a fraction and it's outside of 1/4. Horizontal stretches and shrinks just happen inside the parent function, so that would be something like f of x equals absolute value of 5x is going to give us a horizontal shrink because it's a whole number and it's inside. So after we stretch or shrink, then we're going to reflect. I remember we have two options for reflecting. We can go over the x-axis or the y-axis. Something that's reflecting over the x-axis looks like f of x equals square root of x, where the negative sign is outside the parent function, whereas if it's reflecting over the y-axis, the negative is inside the parent function. So something like this, an example of this would be f of example, f of x equals the absolute value of negative x, which is going to give me a reflection over the y-axis, since the negative is inside the parent function, whereas f of x equals negative absolute value of x is going to give me a reflection over the x-axis because it's outside. So I move left and right, I stretch and shrink, I reflect, and then the last thing I'm always going to do is move up or down. And I move up when I take my parent function, so f of x equals sine of x, and I add a number outside, that moves it up. If I take my parent function, f of x equals sine of x, and I subtract a number at the end all the way outside, that moves it down. So for example, if I have f of x equals x cubed plus 5, that's going to move up 5, whereas f of x equals x squared minus 3 is going to move down 3. You guys have seen this already, all separated, but we're going to put it all together now, in which case the order is going to matter. So when I look at something all together, I can have as many transformations as possible. The first negative, tells me if it reflects over the x-axis. The a, the number multiplying outside, is going to be my vertical stretch or vertical shrink. Remember, this is a whole number. This one is a fraction. the negative inside reflects over the y-axis. Multiplying by a number inside as a horizontal stretch or a horizontal shrink. It's a stretch when it's a fraction. It's a shrink when it's a whole number because it's opposite. The C, when it's negative, moves it right. When it's positive, moves it left. And the last thing that I'm going to look at is my up and down. Positive for up, negative for down. So looking at all of these things, I can decide what's happening. So for example, if I look at f of x equals negative 2x plus 3 all cubed minus 4, and it wants to know what's happening. The first thing I'm going to do is I look and I see, okay, I have a negative outside. This negative outside tells me it reflects over the x-axis. This 2 is multiplying outside. So that tells me it's a vertical stretch. And I know it's a stretch because it's a whole number. If it was a fraction, it would be a shrink. The next thing I have to look at is my plus 1 inside the parentheses, which is my left or right. Since it's positive, it's going to go left 1. And then the last thing I have to look at is my minus 4 all the way at the end, which tells me down 4. So if I was going to actually graph this, the first thing I have to do is my left or right. So I know that my parent function for x cubed looks like this. The first thing I have to do is move it to the left 1. So now I have a graph that's left 1. Then I have to stretch or shrink it. Since I'm stretching it, it's going to physically make the graph taller. It's going to just make it skinnier at the same point. Then I have to reflect it, which is going to take it now and keep it at the same point, but flip it. And the last thing I have to do is move it down 4. So since I'm here and I'm moving down 4, I'm going to 1, 2, 3, 4. And my graph looked like this. So I have to make sure I do it in the correct order in order to decide what my graph is going to look like. If I look at this next one, the trick with this next one you'll notice right away is that this negative 2 is stuck to the x, where in every example we had before there was a parenthesis right around the x. Even up when we wrote it up here, the x was totally separate in its parentheses. It can't be touching the reflection or the horizontal stretch and shrink. So since in this example it is touching the horizontal stretch and shrink, in order for us to decide what's happening here, I need to go in and factor out the negative 2x. So I need to separate this negative 2x, or this negative 2, from the x. I want that x to be separate. So I'm going to separate them. When I do that, I also have to take this positive 8 and factor it out here, which gives me a negative 4, because remember I just do positive 8 divided by negative 2 since that's what I was factoring out. And now my real equation that I'm looking at to transform is 1/4 negative 2 x minus 4 all squared minus 1. I can't identify my transformations until everything is completely separate. Now I can go in and say, okay, I'm moving to the right 4. So the first thing I'm doing is right 4. Then I have a horizontal shrink of 2. I also have a reflection over the y-axis. Y-axis. I have a vertical shrink of 1/4. And the last thing I have is a down 1.